Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This is our first video on this newly launched YouTube channel under title Electrodynamics by Rajput Abdul Waheed Bhatti. Okay. Dear students, in this first video, we will solve 3 problems of electrodynamics. Okay. All these 3 problems have been taken or chosen or selected from the book Elements of Electromagnetics by Matthew N.O. Sadiq. Okay, irrespective of the exact pronunciation of the name, perhaps Sadiq or Sadiq. Okay, Elements of Electromagnetics by Matthew N.O. Sadiq. Dear students, this author has another book, Fundamentals of Electric Circuit. Fundamentals of Electric Circuits, in which there is another author, Charles Alexander. Okay, we will follow that book in our newly proposed YouTube channel under title Electronics by Rajput Abdul Waheed Bhatti. Okay, in electronics we will follow the book of Matthew N.O. Sadiq and Charles Alexander, Fundamentals of Electric Circuits. While in this book, in this channel, which is under the title Electrodynamics by Rajput Abdul Waheed Bhatti, we will follow the book of Matthew N.O. Sadiq, Elements of Electromagnetics. Elements of Electromagnetics. Okay. In this first video, we are going to solve 3 problems from this book. Okay, so as usual, we first come to statement. Electrodynamics problem number 1. If A is equal to 10ax minus 4ay plus 6az and B equal to 2ax plus ay, find the component of A along ay, the magnitude of 3a minus b, a unit vector along A plus 2b. Okay, dear students, actually such problems are of very initial level, very basic level, but despite the fact that they are very easy and very simple, because these problems are included in this book which we are going to adopt, so definitely we will also start from the same problems, whether they are easy or easier or easiest. Okay, first problem, first is component of A along AY. Okay, dear students, here along AY component is minus 4, quite easy. Okay, school level physics. Okay, so answer of part A is minus 4. Now we come towards part B. What is part B? Is magnitude of 3a minus b. Okay, first we will find 3a minus b, which becomes equal to this and so this. Then we will find magnitude. Okay, its square plus its square plus its square, it becomes 1277. Okay, now third part is a unit vector along A plus 2b. Okay, let C is equal to A plus 2b. Okay, because we have to find a unit vector along A plus 2b, so we assume that this A plus 2b is equal to C. Is equal to C. Yes, students, here one thing more is more important, that in vectors or vector analysis, the term along conveys a different sense than parallel. Okay, So in our problems relating to vectors or vector analysis, whenever we use the term along, then it will be meant a vector in the same direction. But when we take the term parallel to, then it means parallel to means both sides, positive and negative. For example, a vector is parallel to x-axis, then its right side is positive while left side is negative. If a vector is parallel to a vector which is along y-axis, then its upper side is positive and lower side is negative. So that is to say, along and parallel are different. Okay, so C is equal to this, C mod equal to this, and now let AC be the unit vector along C vector. Then this implies that AC equal to C vector over C magnitude. So it becomes equal to this plus this minus this plus this. Okay, counter check. If we take care of all these three, then its magnitude of AC must be equal to 1. And it is really 1. So our solution is exactly right. Okay, so this is that vector, and this is correct because its magnitude becomes equal to 1. Okay, now problem number 2. Given vectors A equal to this, B and B equal to this, determine A plus B magnitude or modulus value or mod. Part B 5A minus B. Part C the component of A along AY. Part D a unit vector along 3A plus B. Okay. Solution. Okay. First we will find A plus B. Okay, which has become equal to this. Now we will find magnitude or modulus value or mod of A plus B, which becomes equal to 7. Okay, this was the required value. Okay, now we come to part B, 5A minus B. Okay, A is given, we will multiply that with 5 and then we will subtract B. It will take this form. Okay, this and it can be written as 0 minus 2 21. Okay, part C is 0. We see what is part C. Part C, the component of A along AY. The component of A along AY, we are seeing that in A there is no AY. AY does not exist. Okay, AX plus AZ. AY is absent, so component of A along AY will be 0. Okay. Now we come towards part D, a unit vector along A plus B. Okay. Same procedure which we adopted in the previous problem. Okay, let C equal to 3A plus B. C vector becomes equal to this, and magnitude of C or mod of C or modulus value of C becomes equal to 77 under root. Let AC be the unit vector along C, then this implies that AC equal to C over C mod equal to this. Okay, this. Now counter check. We check that square of this plus square of this plus square of this under root becomes equal to 1. Then our answer is correct, because magnitude of a unit vector is always unity 1. Okay, so it is becoming equal to 1. So we have solved our problem correctly. This is just a counter check. It is not necessary. Okay, this is for our own satisfaction. Okay, now note along is not equal to parallel. As I have already explained this point, that in vector analysis the term along takes a different meaning in the same direction. But when we use parallel, it means both plus and minus are going to be taken into consideration. Okay, because a vector parallel to another vector may have positive and negative value, whether it is along x-axis or along y-axis. Okay. Problem number 3. Points P and Q are located at this. Okay, calculate the position of vector RP, the distance vector from P to Q, the distance between P and Q, a vector parallel to PQ with magnitude 10. Okay. Now we come to its solution. Part A, R vector RP becomes equal to this. This is the same which is P, okay, because position vector is always taken with respect to origin, which is 0, 0, 0. So RP will be the exactly same as P. Okay, so we see whether what is P. P is 0 to 4. 0 to 4 and RP is also 0 to 4. That is 2 plus 2AY plus 4AZ. Okay. So it is quite clear that RP, whenever we take into consideration this, it becomes only equal to P, because position vector is always taken with respect to origin, which in 3-dimensional space is 0, 0, 0. Okay. Now we come to part B. Part B. What is part B? The distance between the distance vector between P to Q. Distance vector between P to Q, RPQ is equal to RQ minus RP. Okay, so here RQ will be same as Q and RP will be same as P. Okay, so their difference will be equal to this, and this can be written in terms of this. Okay, both these expressions are correct. Okay, now we come to part C. What is part C? Part C is the distance between P and Q. We know that distance between 2 points P1, X1, Y1, Z1 and P2, X2, Y2, Z2 in 3 dimensions, that is space, is given as D P1, P2 equal to X2 minus X1 whole square plus Y2 minus Y1 whole square plus Z2 minus Z1 whole square whole under root. Hence, D distance between this and this is equal to RPQ mod or modulus value or magnitude or absolute value. Okay, becomes equal to this equal to 11 under root, and this is becomes equal to 3.317. Okay, this is part C. Now we come to part D. Part D, a vector parallel to PQ with magnitude of 10. Okay, here parallel becomes. Here we will see what difference occurs when we use the term along and when we use the term parallel. Okay. A RP equal to this we have previously calculated. Here RPQ equal to this minus this we have previously calculated. Okay. These parts have been previously, yes, sorry. Mistakenly I have started part A. We have to go to part D. Okay, part D. This is part D. Part D from B we have this is we have already calculated part B. From C we have already calculated. Okay, we are solving here part D, but in part D, part B and part C are being reused. Okay, let us see. A vector parallel to PQ with magnitude of 10. Okay, we are solving part D, but in part D, B and C are being reutilized. Okay, so in part D we say that from B we know that this is this, and from C we know that this is equal to this. So it means if we take this value in the numerator and this value in the denominator, then we will be able to find a unit vector in this direction. Okay, so this implies that if we do so, we get a unit vector along RPQ. Okay, the unit vector has become equal to this, and this vector is along RPQ because we have followed simple method, which is for along term. Okay, now we come to parallel term. Okay, this implies that here if we use the sign plus minus, then here also plus minus will appear, and here plus minus will also appear. Okay, so this implies that plus minus RP over RPQ over RPQ modulus value equal to plus minus this becomes equal to unit vector parallel to PQ. Okay, what is the difference between the unit vector along and parallel? That in along there is no positive negative sign, there is no such sign. It means there is only plus sign, because when there is no sign it means there is plus sign. Okay, but here because we are taking into consideration the parallel situation, so both plus and minus sign will be taken into consideration, because a parallel vector and along vector have this difference. Okay, so this is a unit vector parallel to RPQ. Okay, here moreover we know that this vector is of magnitude 10. Okay, so far we have found only a unit vector, and it is given that in problem D magnitude 10. Okay, when its magnitude is 10, it means the unit vector is to be multiplied with 10. So this becomes equal to 10. So when we will simplify, it becomes equal to this, equal to required vector. Okay, so what a procedure we have adopted. We have just find, first we have find a unit vector along PQ, then we have find a unit vector parallel to PQ by adding plus minus sign, because parallel situation requires a different formulation. Okay, then that unit vector is multiplied by 10 because 10 is its magnitude. Okay, and this is the end of our first video. Till next video, Allah Hafiz.